Understanding 1 billion colors, the power of 10-bit color depth. The core of digital color, bit depth. The claim of 1 billion colors on a display refers directly to its color bit depth, a crucial specification for image quality. It is a technical measurement of how many discrete shades a display can produce for each of the primary color channels, red, green, and blue, RGB. Higher bit depth translates to a vastly expanded color palette. The standard, 8-bit color. For decades, the industry standard has been 8-bit color depth. In this system, each of the 3 RGB channels uses 8 bits of data. This allows for 8 is equal to 256 distinct shades per channel. Combining the 3 channels results in a total color count of 256 *256 *256, which equals 16,777,216 colors, famously known as 16.7 million colors or true color. Stepping up to 10-bit. The 1 billion color specification is the result of 10-bit color depth. Here, each RGB channel uses 10 bits of data, allowing for 10 is equal to 1024 distinct shades per channel. The massive leap in total colors comes from this combination, 1024 *1024 *1024, which precisely equals 1073,741,824 colors. Why 10-bit is called 1 billion colors? For simplification in marketing and general specification sheets, the precise figure of 1.073 billion is rounded down to the more digestible and memorable phrase, 1 billion colors. This specification is key to delivering modern high dynamic range (HDR) content, which requires a much larger color space, eliminating color banding artifacts. The primary benefit of moving from 8-bit to 10-bit is the near elimination of a common visual artifact known as color banding. This appears as visible, abrupt steps or stripes in subtle gradients, such as a clear blue sky or a dark shadow. The 1024 shades per channel in 10-bit color provide 64 times the number of shades for intermediate tones, creating perfectly smooth transitions. The need for true 10-bit panels. It is essential to distinguish between a true 10-bit panel and an 8-bit plus FRC panel. A true 10-bit panel has native 10-bit circuitry. However, many mid-range displays achieve the 1 billion color claim using frame rate control, FRC, a dithering technique that rapidly alternates an 8-bit pixel between two colors to simulate a shade in between. Frame rate control, FRC, explained. FRC rapidly flickers pixels between neighboring colors so quickly that the human eye averages them out, perceiving a synthetic intermediate shade. While FRC is incredibly effective at reducing banding and delivering a visual experience very close to true 10-bit, it is technically an emulation rather than native display capability. The HDR and wide color gamut connection. Displays with 1 billion colors are almost always paired with wide color gamut, WCG, technology, often covering standards like DCI-P3 or Rec. 2020. A higher bit depth provides the precision, more steps between colors, while a wider gamut provides the range, more vibrant and saturated colors. Both are prerequisites for proper HDR rendering. System requirements for 10-bit output. To actually utilize the 10-bit color depth, an entire chain must be compatible: the display panel, true 10-bit or 8-bit plus FRC, the graphics card, GPU, the cable, e.g., DisplayPort or HDMI 2.0 plus, and the content itself, which must be encoded in 10-bit. If any link is 8-bit, The output will be limited to 16.7 million colors. Audience impact: professionals versus consumers. For color-critical work in professional photography, video editing, and graphic design, a true 10-bit display is a non-negotiable asset for color fidelity and accuracy. For general consumers and gamers, 8-bit plus FRC is often sufficient, providing a significant boost in visual smoothness without the premium cost of a native 10-bit panel.